In this video, we will find the derivative of the function f of x equals sine of the square root of x using first principles. We'll carefully apply the definition of the derivative and simplify step by step. First, let's recall the definition of the derivative. The derivative is the limit as h approaches 0 of f of x plus h minus f of x, all over h. Now we substitute our function into the definition. That gives us the limit of sine of square root of x plus h minus sine of square root of x, all over h. To simplify the numerator, we use the sine subtraction formula. Sine a minus sine b equals 2 cosine of the average times sine of half the difference. Applying that identity, we rewrite the derivative as 2 cosine of the average of the square roots times sine of half the difference, all over h. Now let's separate the expression into three parts. We will form a sine over its angle and a remaining fraction involving the square roots. We know that sine of u over u goes to 1 as u goes to 0. So the middle factor becomes 1. Now we simplify the last factor by multiplying by the conjugate. Now the numerator becomes h, which cancels with the h in the denominator. So this factor becomes 1 over 2 times the sum of the square roots. Now we can take the limit. As h goes to 0, the cosine term becomes cosine of square root of x, and the denominator becomes 2 square root of x. So the derivative is cosine of square root of x over 2 square root of x. Let's quickly visualize the original function. Here is the graph of y equals sine of square root of x for x greater than or equal to 0. Notice how it oscillates slowly at first, and then more rapidly as x grows. Great work! We have derived the derivative from first principles, and the final answer is cosine of square root of x over 2 square root of x. Thank you for watching.